My name is Rafael Benevides. I work for Red Hat as Director of Developer Experience, and essentially, I'm a Java developer, okay? Usually what I like to do when I'm not traveling and speaking at conference, I like to build and fly my own drones. And usually people ask me, why you prefer to build your drone instead of buying a drone ready to fly? And I always say that's very similar to buying a laptop or building your own PC your gamer PC, okay? Because when you are building your drone, I have the freedom to choose the propeller size, the motor, the battery, the controller, the receiver, everything else. It's just like when you build a PC. You have the freedom to choose the size of the SSD, the memory, the video card. So somehow this is related to microservices. But I say that with microservice is even better because I can change the technology of the microservice while it's on production. With drones, I cannot change the motor while it's flying. So microservice is even more interesting. Before talking about microservice, let me invite you to join the Red Hat Developers Program, who were in my previous talk heard about that. It's where you can find free resources for developers, just like these ebooks, microservice for Java developers, building reactive microservice in Java, migrating to microservice database, introducing STO service mesh for microservice. So a lot of resources. And since we are in a Java conference, I cannot forget to mention about microprofile. It's a specification for building microservices for Java. The URL is just microprofile.io. Okay, so let's start specifically about microservice. Microservice is all about agility. It's nothing more besides that. It's not because it's cool. It's not because it's easy to develop, easy to maintain. Instead, it's opposite. It's hard to develop, it's hard to maintain. And even so, people are interested in microservices. And the only reason for that is agility. Of course, there are two realities for, hold on a second. Even so, people are interested in microservices. Of course, there are two realities. The greenfield, where there's nothing built and people want to start producing microservices, just like a startup, or the reality of, I believe that majority of us, we are working with applications that were built for 5-10 years ago, and we decide that we want to produce microservices. So no matter if we are talking about greenfield or brownfield, before adopting microservices, we should go to a kind of evolutionary process. For example, we need to adopt DevOps practices. Then we should adopt a self-service on-demand Elastic infrastructure, usually where we are talking about the cloud. Okay. Then we start talking about automation with tools like Puppet, Chef, Ansible. With automation, it's easy to start having CI/CD deployment pipeline. With CI/CD deployment pipeline, it's easy to have advanced deployment techniques like A/B tests, blue-green deployment, Canary deployments, and who knows? Then you can become the next Silicon Valley.com startup of the universe. Where I got this information, it's not from my head. I got from this article from Martin Fowler, where he mentioned that you must be this tall to produce microservices. So he mentioned all those things: self-service on demand, DevOps, automation, CI/CD, deployment pipeline. Let's start thinking about producing a microservice. Suppose that we are all here and we decide together, we are all developers, right? We are Java developers. So let's produce a microservice. The first thing is to decide what operational system we will use. Should we use Windows? Should we use Linux? Where we will deploy that? In production. We are not talking about our laptops, okay? Then we need to choose the JVM. We will use JVM 8, 9, 10, 11. Then our application server. Then we need to also decide that we will use independent wars, or we will place everything inside an enterprise archive. And then we decide to create our war files. Then we extract some parts of the code in libraries. Then we start reusing those libraries in new wars and place new entities and third-party Maven dependencies in other jars. And when you realize you have a wild beast to maintain, right? It's huge. And to maintain this huge beast, this wild beast, we have a team composed of programmers, business analysts, project managers, operators, DBAs. Okay, so we would split this group of developers and have more people working together in this software. But the reality is not that everybody works with everybody. We have modules, right? We have the sales model, we have the security model, we have the data warehouse, the finance model. So probably part of us would work in different models of the application. And let's be honest, when I said on production, it's because no matter if you have the latest and the coolest technology running on your laptop, if it's not running on production, it does not have any value for the company. It doesn't have any value to the customer, and it doesn't have any value to you, because if it's only on your laptop, it was just a lose of time, right? It needs to be there to have value, there on production. And once that we receive a request to implement something, usually it might take 24 hours to, 24 weeks to specify a new feature, implement, test, deploy, and make sure that everything is working, right? Of course, we can adopt certain practices like DevOps practices, Agile practices, and reduce that amount of time to 12 weeks, 9 weeks, 6 weeks, or 3 weeks, which is a week of a sprint, if we are talking about Agile practice. In a high-trust environment, sometimes you can have one deployment a week. But how can you go faster than that? Because there is a book called the Phoenix Project that was written by Jenny Kim, and he talks about 10 deploys a day. It's more than one deploy an hour. And how is that possible? The only solution is when you break your monolith in smaller pieces, because with independent pieces, you can deploy on the first week the part A, C, and D. On the following week, we will deploy a new version of A, then H and G, and so on. So when you break up your monolith in smaller pieces, you are gaining agility, because the independence helps to achieve agility. In one team, you can work with Java, with Oracle. Another one can use Python with MySQL. Another one can use Go with Postgres. It's about independency. It's about what's the best technology to fulfill that specific use case. And again, you don't need to wait for one piece of software to be deployed so that you can refactor your application. You need to be able to deploy at any moment. Of course, when we are talking about microservices, in every talk, on most of the talks, we will hear about the Conway's law that basically says if your or communication infrastructure is a mess, very likely your application will be a mess as well. But if you have a strong, a well-defined communication infrastructure, very likely your application will be very well defined and structured because it tends to be a copy of each other. The software that you produce tends to be a copy of the communication infrastructure. So most people here, when see this kind of picture, think, that's easy. I saw that. I know how to integrate these different pieces. It's just place an enterprise service bus in the middle. No, enterprise service bus is about SOA. And SOA, it's not microservice, and microservice is not SOA. Of course, when we talk about SOA, we are talking about smart smart pipeline and dumb endpoints. So the pipeline was responsible to convert, to enrich, to route, to transform the message. In a microservice, it's opposite. It's about smart endpoints and dumb pipelines. Of course, SOA still have value nowadays, but to integrate different applications. When we are talking about microservices, we are talking about the same application divided in small parts. Okay, we have some characteristics about microservice. The first one is being deployment. It's being independently deployable, right? It's the first. It's the only reason that we produce microservices. To be able to deploy them individually, we need to have a focus on API, right? Of course, we have a well-defined API, and then we can change the implementation, but sometimes we need to change the API, right? It's normal, it's expected. It's not that often, it's not daily, it's not monthly. Sometimes once a year we can change the API, but for that, we need to have an evolutionary design. Plus, decentralized data management. So if we have 100 microservices, very likely we will have 100 databases. Imagine the situation, you have a customer table and you decided to refactor because your application needs it. And then you cannot deploy because the whole application needs to refactor as well. Then you are not being able to independently deploy that model. So that's why at least you need to be 100 schemas. You can have one server, that's fine. It's not proper, but it's fine as long as you have different schemas for each part of your software. Of course, we have several other principles, but due to the time, I cannot go deeper on each one of them. But related to the data management that I've talked, when we talk about having multiple databases in our company, it's easy to have our DBAs trying to kill us. What you're trying to do, you are creating duplicate data. The data is spread everywhere. So maybe you can buy him this book and give him as a gift. Or even this book that you don't need even to buy. You go to the Red Hat Developers Program, developers.redhat.com, and download it for free. I'm giving the link to you. So download, give it to your DBA, and probably he will be your best friend forever. Who knows? Until the next technology arrives. Okay, but what I want to show you is a demo of a Hello World application that covers most of the things that we need to care in a microservice application. And you might think, oh no, come on, another Hello World? Everyone talks about Hello World, but I guarantee to you that's the best Hello World that you ever see. And one of the reasons, here I have different microservices implemented using different technologies. So for example, it's a hello that returns hello in Spanish. It was implemented using JavaDay on Thorntail / microprofile. I have another one that replies hello in Portuguese. By the way, I'm Brazilian, okay? My native language is Portuguese. It was implemented using Spring Boot. By the way, let me do something here that I forgot, which is open the QuickTime to record at least the demo, right? Let's do it now. Okay, QuickTime, new screen recording. I don't need to record the audio because we are recording already, and there we go. Okay, I have another hello that replies in French. It was implemented using Node.js. I know that we are in a Java conference, but we have Node.js as well. We have an API gateway. We'll talk about that more. And Vertex. By the way, Vertex is an framework to implement reactive applications using the JVM. So it's all about Java also. So we have, but it returns in Hawaiian. Okay. So as I said, it's a very cool application. And all of these microservices have been deployed on my OpenShift instance. OpenShift, by the way, it's very similar with Kubernetes. Okay, so and I showed that in the previous section. If I get kubectl, kubectl, and use kubectl get pods, for example, or kubectl get service, I can do the same with OpenShift. OC, OpenShift client get service, OC get pods. So when we are talking about OpenShift, we are almost talking about Kubernetes. So all of them are deployed here. So I have Aloha, the API gateway, Bonjour, front-end, Hola, Hola in Portuguese, and other resources. They all have been deployed. Now let's think about the properties, the characteristics that a microservice should have. No matter what language we are talking about, no matter if it's Vertex, no matter if it's Spring Boot, no matter if it's Node.js, all microservices should have these properties. And we will go through each one of them. We need an API, right? We need a discovery, a way to find that microservice inside the cluster, inside our network. We need a way to invoke that microservice. Is it a REST endpoint? Is it messaging? Is it synchronous or asynchronous? We need elasticity, because probably another reason to use microservice is because you can scale just one part of your application. We need resilience, because another principle of microservice is that it will fail. It's not that it might fail. It will certainly fail, and you need to be prepared for that. Pipeline, how you get your code from your Git repository and place it on production. How to perform authentication, logging, how do we aggregate logs and collect them, how perform monitoring, tracing. So let's see. API is easy, right? And every language has its own API. If we use JavaE, now it's called Jakarta, probably we will use JAX-RS. If we use Spring, there's Spring MVC. Vertex has a web router. Node.js offers Express. So it's easy, okay? By the way, here I'm using, let me just open here one endpoint, because now I'm talking about discovery and invocation. So let me open, for example, the Bonjour. At this URL, API-bonjour, you have a reply, Bonjour, and the name of the container. name of the host, okay? And how I can perform service discovery? Since I'm running inside Kubernetes, some people use Netflix OS as Eureka and Ribbon, but inside a Kubernetes cluster, I can find easily one container or another. For example, let me open a terminal here. I'm opening a terminal inside the container called Aloha, right? So I'm inside Aloha. I can, for example, ping Hola. And here I have the name resolved automatically. If I'm pinging Bonjour, it's another IP address, but again, I was able to find it. Ping Aloha. So see, I'm inside Aloha, but it never replies my internal address, 127.0.0.1, or my internal IP. It always replies the IP of the cluster, the service, the IP of the service, because the Kubernetes has this concept of servers, and it has cluster IPs for every service. Okay, so it's easy. It was for free. Okay, so let's continue. Since demo, discovery, and invocation, we gained that for free with Kubernetes. Now we need to see some patterns. One of the most used patterns is to have the browser as a client, right? So imagine a screen just like that, just like Amazon. Each part of the screen will come from a different microservice. So the pricing will come from the price engine, the reviews, details, and specification. But imagine if one microservice fails. We will not provide a blue screen saying, oh, come on, my application is offline, we are facing technical issues, try again later. No, it's just a silly microservice. So, in that case, you can provide a fallback. And in a fallback, since it's running inside a mobile device, you can use the GPS, and you don't know how many computers you have in that store, but you can show where is the closest store. That's a fallback implementation. You can use also an API gateway. Most people think, what is an API gateway? Is it a product that I can buy from a vendor? No, it's just another microservice that doesn't care about any business logic. It's only to avoid the browser have to connect to each microservice. So the API gateway will be responsible for that. Okay. Of course, it can also translate some protocols. Sometimes one microservice is not browser friendly. It can talk to that browser, to that microservice, and then expose a REST endpoint so the browser can talk to it. Okay, and of course you can have a chained invocation, because one microservice alone is not enough. Microservice A needs to call B, to call C, and etc. But what happens if something goes wrong in the middle? We don't want a cascading failure. What we want is that the previous endpoint be smart enough. That's why we say that microservices are about smart endpoints and dumb pipelines. So the previous endpoint should take the decision. Should I call the next one? What should I do? So it's a responsibility of the implementation. Of course, what's the decision? It's all about the use case. It's not me, it's not you that will say. It's the use case that will have the answer. What should I do if this microservice here fails? Okay? And it's perfectly fine to have a mixed architecture of them. So let's see a demo about elasticity. Here, one of the microservices is the front end. I can see these different patterns here. So I have the browser as a client. So every time that I access it, I will have the browser calling each microservice. I can have the API gateway, where I will only one single call is made to the API gateway, and it will collect the array of strings. It will collect the strings of the microservice and create an array of strings and then return it to the browser. And by the way, the implementation that I used here for an API gateway is using it used Apache Camel. Apache Camel is really good for integration. That's why it was really simple to use it. Or you can have a service chaining. To scale, to perform elasticity, you gain that for free as well on Kubernetes. Because you can scale to 1, 2, 3 replicas here, or if you just delete one container, for example, if I delete Bonjour, Kubernetes will restart another replica of Bonjour to replace, so it's managed automatically by the cluster in a way that my application will always work. Let's continue. What else we have in a microservice architecture? We have circuit breakers. By the way, there is a talk that I'm really excited to watch from a talk of Nicholas, who will talk specifically about circuit breakers, and he'll talk about the Netflix OSS histories, and it will probably complement this talk. Imagine a situation where the service B is slow to respond, right? It's slow, it's not offline. What we do, what our users, they do, they click refresh, 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 several times. And what it happens? Service B will not get faster. It will get slower because it will have more things in the queue to process. And A will start to be slow as well because they will open a thread, connect, and the thread will be waiting an answer. Then you click refresh again and it creates another thread. And when you see you have the thread pool full in a way of threads in a wait state. So it's good to have a circuit breaker. And one implementation of a circuit breaker can be used using Hystrix, and Hystrix provides a nice dashboard where for each microservice that you have, you will have some information like the number of success requests, number of thread timeout, thread pool rejections, the latency, number of hosts, a graphical volume, the percentage error per second, the request rate, and plus if the circuit is opened or closed. Because if Hystrix, if the service B is slow to respond or is getting an error, Hystrix will disconnect. It will open the circuit and will provide a fallback. So you can check the status of the circuit here. I forgot to mention, but if something goes wrong, you can just provide a Java implementation. What will happen if something goes wrong? So let's demo that by removing, I will scale to 0 here. My service called Aloha, right? So I don't have any Aloha service. Let me try to reach Aloha here. I will invoke. You can see that it failed. Let me invoke here the API gateway. No, not here. Look at this small detail. It's slow, right? Every time that I try, it tries to connect, gives a timeout, and I don't see the result. What I will do here also is open the Hystrix dashboard so you can see the reflect of that in the Hystrix monitor, the Hystrix dashboard. So it's loading, API gateway pattern. My Hystrix dashboard is not working, but never mind. what I will do, what our users usually do. I will click refresh several times. Now, note here, the circuit opened, and you can see a fallback for every one of them, and it's failing fast. The same here, right? If I click several times, the circuit now is opened, and it's failing fast until I restart my container, and when it's running again, let's wait. By the way, the circuit's closed only for a short period of time. Then if I try again, it tries to connect and then reestablish this circuit. Now I have plenty full connection. Okay? What else we need in a microservice? We need authentication. Now imagine that you have those 4 microservices. Every time that you reach a microservice, you receive a login screen. Login, that obviously doesn't work. So we need a single sign-on implementation. And for a single sign-on, there is how can I say, a specification that provides JSON Web Tokens, JWT, that provides a token with the information for authentication. And here, note here, if I go to this first tab and I try to access, I'll get unauthorized, right? It's saying, no, you can't access. I don't know who is you because I'm not authenticated. If I click login, I will be redirected to Keycloak. I don't know how many of you have heard about Keycloak, but believe me, I didn't write one single line of code to have this authentication page. This is provided by Keycloak. Let me open the Keycloak administration so you can have an idea on what I'm talking about.
Self-implementation, right?
It's
Self-implementation. Custom identity access by the system.
Yes, that's true. So, for example, to create this login screen, I just created a realm here, so I can even say, hello, MSA microservice for Lviv. If I save and refresh this screen, there we go. If I want to enable forget password, I just modify here, and I have forget password. If I want to enable user registration, I just enable it here, and I can now register a new user. So I get that for free. But even better, then you by the way, you can try that now. If you go to this, if you take your mobile phone, your laptop, and go to frontend -hello world-msa.app.rafaelbenevides.com. I know that's a big address, but what you can do is have different identity providers. So Keycloak has support for Twitter, Facebook, Google, LinkedIn, Microsoft, Instagram, several identity providers. Since we are in an IT conference, I created one identity provider that I will enable now that will get your information from GitHub. So if you go to this URL, probably you can click here, log in, and you will be authenticated with the information coming from GitHub. Now I can click refresh. This one is stuck. And you will see that the information on the token was propagated to the microservices. This is a secured resource. You are logged in as your name. And you might ask, okay, but why I'm receiving unauthorized here? It's because this microservice needs authentication. This other here needs authentication and authorization. So I don't have, in my database, my user doesn't have a role called users. Let me give this role. Now I can log out to get a new mapping. And if I log in again with the GitHub credential, I can refresh. Now I have access to those resources. And again, I didn't write a single line of code. That's awesome. Okay, what else we have? I told you that this is one of the best Hello Worlds that you ever seen, because you see how many features you can try with Hello World, with those with Hello World. Logging. Logging, I will not demo to you, but most of you can imagine that the suggested stack called EFK, Elasticsearch, Fluentd, and Kibana is a recommended way to collect the logs and analyze the logs. Because you saw, I could have scaled my application to 3, 4, 10, 100 replicas. How can I manage the logging of 100 replicas? Only using Elasticsearch, Fluentd, and Kibana, because it will aggregate those logs. Okay. Monitoring. Monitoring, you have that for free also in OpenShift. So if you can take a look here. For this specific container, you have information about memory, usages of CPU and network. If you have more than one replica running, let me see, where is it? You can see the metrics in different time ranges, last day, last hour. Okay, so that you gain for free. Let me see something else here. Oops. And I haven't enabled, but for Java applications, you can connect to Hawkler and collect data from the JVM, besides those metrics from the container. So that's also really, really simple. Now, tracing. Tracing is really interesting. Tracing became very popular with Zipkin, but there was a moment in time that CNCF, the Cloud Native Foundation, decided to create a specification called Open Tracing, and one of the most famous Open Tracing implementation is Jagger. Jagger will trace your request. So let me open here the Jagger dashboard. So you can see that every invocation that I did here, you can find them along the time on the Jagger dashboard. So for example, I can see here for the API gateway, all the invocations in parallel, and also details of this invocation. You can see the graphic of dependencies. The API gateway invoked each one of them. I have had a parallel invocation, which broke here because I've removed the link one time. And tracing is also part of a microservice implementation. But let's talk about advanced deployment techniques. With OpenShift, you can have blue-green deployments for free. It's where when you place your software in a new environment and you just switch the route from one version to another. I had a question about that on my previous talk, and basically what I will demo is switching. For example, the API gateway. I have another implementation here that I can change. Try. You can see here now that's saying updated. And if something is not the way that I expected, I can switch back my route to the previous application, the previous version. And then if I retry here, I will see the previous version. Okay, what else? Pipelines. So everything starts with a git commit. Let me open here while true. Look here at this microservice, the Aloha microservice. I don't know how many of you speaks Hawaiian, but there is a typo here. It's saying Aloha instead of Aloha. So I can go to the repository, fix it, and let me show. I'm fixing it inside GitHub, but GitHub has a webhook connected to my server that will notify my server, and my server will start a pipeline. Builds pipeline. So as you can see, it started some seconds ago. This pipeline is defined here using this Jenkins file. So what you will see is that we'll perform a checkout, Maven build, create an image, run the automated test, because one thing important in a CI/CD pipeline is to have a good battery of tests. Otherwise, you are just automating the introduction of bugs in production. So automated test, then promote the image and wait for human approval. That's exactly what you are seeing here, because this pipeline, by its configuration, you will look at the Jenkins file. Okay? And of course, once that it reaches the quality assurance, I can test and finally promote it to production. And one way to place my code on production is using a Canary deployment. Do you know why it's called Canary? Let me tell you an interesting story. The British coal miners, they used to carry a small canary with them inside the mines. So if there was a gas leakage, they know that the canary would fall. Hopefully it wouldn't die. But if it died, there was the canary resuscitator. So they can make the canary live again by giving him some oxygen. And the idea in the software is you start sending requests to the Canary version. If everything goes fine, then you start to increase the number of requests on that Canary deployment until it becomes to be the whole. So you can see here, the code is waiting for approval, but on production, I'm still having the old version. So I will open here, log in my Jenkins instance, and just answer, okay, proceed to production. Then it's proceeding to production, and what it's doing on production, it will create, let me place here 3 replicas, okay? So every number that you see here is the number /name of the container. And you can see that it created another deployment. And now you can see we have one item fixed here. And then I can now control manually my deployment. So for example, I can scale this to 1, I can scale this to 3, and you will see it changing here from one version to another. Okay, come on. There we go. We have an Aloha most of the time and one Aloha. If I stop the container, now only the Canary version is running. So I was able to fix it. Oops. Just in time, perfect. Okay, so to conclude this talk, I just like to mention the following. Martin Fowler said, if you want to adopt microservices, don't go directly to a microservice architecture. It's risky. You will face dragons, lizards, okay? First, develop a monolith. Then you extract one microservice. And then you will have as the complexity rises, you will continue breaking and discovering the boundary to finally have a complete microservice application. Okay, thank you so much. Or you can reach me also by Twitter.